In the name of Allah, the most merciful and most beneficent. Assalamu alaikum and a very good evening to all of you. Respected distinguished guests, dear colleagues, ladies and gentlemen. On the behalf of AWS Community Pakistan, this is Amna Mir signing in as your host. And I extend a warm welcome to you in this fourth episode of AWS Beginner Series. Today's webinar is about Intro to Serverless. And also, you will get to have a hands-on lab on AWS Lambda. For that purpose, we have Mr. Hussain Mansoor with us. Mr. Hussain has been certified by AWS and Scrum twice. He has been working in the software industry for more than a decade with a master's in software engineering from a university in England. He has been leading a team of cloud architects and engineers for an MNC in Kuala Lumpur, Malaysia. The team manages applications which have millions of users each month. Speaker's core area of expertise include cloud native development, microservices, resilient and cost-effective scalable solutions on cloud technologies. So without wasting any time, I would like to call him to take over and enlighten us with his knowledge. But before that, let me quickly tell you how this event is going to proceed. So first of all, our speaker will complete his presentation and then he will answer some of your questions from the comment box. One more takeaway of today's webinar is that AWS Community Pakistan will be giving away AWS credits of worth 25 US dollars in a total of 10 participants of this webinar randomly. So any of you can be one of the lucky ones. So that's all from my side. Over to you, sir.
Assalamu alaikum everyone. My name is Hussain Mansoor. Welcome to Introduction to Serverless and AWS Lambda Hands-on Lab. So I welcome you all to this Beginner Series episode 4, and let's hope that you will learn something out of this presentation and this lab. So without further ado, let's start. So a little bit of my intro is that obviously, my name is Hussain Mansoor. I am AWS Dev AX mentor, which means that I help communities with AWS labs, workshops, seminars, presentations. I did my bachelor's in computer science from FAST Karachi, and I did my master's in software engineering from Malaysia and UK. I have a dual degree master's. I'm working as a lead systems engineer, or you can call it site reliability engineer or DevOps engineer. Basically, we are cloud architects who manage cloud applications. More detail, if you want to know about me, you can find out at my website, hossan.dev/about.html. I also have a side hobby to run this YouTube channel, and I try to cover AWS in Urdu. And the channel name is All About Cloud, and you can search for it on YouTube. And this is the icon for easy referencing. Okay, so about the topic of today, these are the contents. Why we need serverless. EC2, you must have heard about other AWS services. So what is this new thing which is called serverless? Why everyone is talking about it, or why I think it's very, very important that everyone of us should learn about it at least, if not use it. And if we use it, then that's going to be perfect. Then what is serverless? And then finally, what are the benefits? And then finally, we will move on to our lab. So let's start. Why serverless? So as you can see on the left-hand side or right-hand side, this is a simple history of cars, where it started and where it is now. The same thing is with compute or technology. Like, it didn't started as AWS or cloud or anything. It has started something which we known as ENIAC. This is a picture of a computer back in 1940s, and basically there were like less than 10 computers in the whole world. in the whole world. There was no concept of personal computer or mobile phone or wireless technology or any such thing. It's a custom built hardware. It means you have to create, develop everything from scratch, and it will do just one thing, mathematical calculations at most. And that's it. You cannot reprogram it for the most part. You cannot modify it. There's no portability because the weight of these machines is in tons. Technology advanced, some changes happened, and then we got these servers, these racks. They are installed in data centers, as we know, and every server has one particular OS, mostly Linux or Windows server. And when you develop application for that operating system. Either the application is Linux or either the application is Windows. Linux application will not run on Windows, Windows application will not run on Linux, vice versa. There's no portability, and it's very hard bound investment, huge capital. You need a lot of network engineers to tie up all these infrastructure together, very specialized engineers to manage the heat issue. And at the end of the day, you have to buy the hardware to run the software and you have to own it. And if it dies for whatever reasons, then you have to purchase again. Then the next is virtual machines. Things evolved. Instead of relying on hardware OS tight coupling, we moved to a hypervisor kind of solution. So there's infrastructure which is still hardware. On top of this hardware, instead of directly installing Linux or whatever operating system, we will install a hypervisor. The hypervisor will manage as a virtual infrastructure for the above layers. The above layers include application plus operating system. The hardware is shared. It means that you can have multiple applications on one system. And if the one particular application dies or operating system fails or there's a kernel panic or something like that, or deadlock or whatever, then you can just throw away that virtual machine and spin up a new one. So apps can be moved from one hardware to another. You can copy paste virtual machines. And this paradigm is called infrastructure as a service or IaaS. The problem is that you still have to pay per hour to use these kind of machines. You have to manage the scaling. So if you want 10 servers, then you need 10 virtual machines. And if one of the hardware fails, which have three virtual machines, then you have to spin up a new hardware and you have to copy paste virtual machines and they will boot up and they will take time and you have to also manage the performance, any bugs, operating system updates, and all such scenarios. EC2 is a classic example. So EC2 Elastic Compute Cloud, AWS servers is nothing but a virtual machine. You still have to manage RAM, hard drive, operating system version, application version, dependencies, and everything. Then recently, I mean in the last decade, something further advanced, a new technology came, and that is called containers. So containers is like further virtualization, uh, further compressing of application and dependencies into individual black boxes. So now we have infrastructure, we have instead of hypervisor, we directly have one operating system. And then we have one thin layer of Docker. This thin layer means that the only dependency your application should have is of Docker. And if your application is PHP, if your application is I don't know, ASP.NET, Java, Node.js, whatever technology, whatever libraries, framework, languages, runtimes, whatever, it will be part of your application. But all of these dependencies, so if you have one application which is running on Java and you have another application which is running on Node.js, you don't need two different operating systems. You don't need two different hardware machines. You can bundle your application in a container, in a Docker, and you can deploy the same machine and the same hardware, right? The Docker is much smaller than virtual machines because virtual machines have operating system built in. Here, the only dependency you have to manage is your own Docker dependency. It doesn't matter if your Docker is running on Linux, which version of Linux, which version of Windows, or maybe some new operating system. You don't have to care about that. The only thing you have to care about is that the server or whatever the infrastructure, underlying infrastructure has Docker. And that's what we call is a platform. So your platform should have Docker. The deployment which were used to take like few days, you can easily do that in few hours. Much better portability. The only requirement is the Docker layer, and you can copy paste your Docker containers very easily. A lot of reusability of components. The Docker is designed as the layered approach. So there is one um, base layer, and then you can have multiple layers on top. So you can have one base Unix or Linux base image, and then you can install Java, so that becomes Unix plus Java, and then you can install Spring Boot, so that becomes Unix, Java, Spring Boot, and then you can add your application on top. And if you want to deploy another application, then you don't have to create the Linux, Java, Spring Boot layer again. You can just reference that layer from another Docker container, and your new image will be ready. So this is perfect, right? This is until now, it is much better than all the previous options. Now what's next? And this is called pass. Now the next is serverless. So as you can see that all these previous slides, all these previous eras, paradigms, we were removing the dependencies further and further and further, and we were shrinking the application and dependencies into smaller layers. Serverless doesn't have any operating system. Serverless doesn't require any underlying platform. Okay, you just write your business logic in terms of functions, in terms of code, in terms of logic, and you just use the cloud service. Well, we are talking about AWS today, so I'll talk a lot about Lambda, which is the serverless service provided by AWS. But the same services are available in GCP, Azure, IBM, Oracle, every Alibaba, every cloud out there. All of them provide some kind of function as a service or serverless. So this is fast, like function as a service. The only thing you have to manage is your functions, is your code. Okay. So what is it? Now we understand like why we need serverless, because we don't have to manage operating system, we don't have to manage hardware, we don't even need Docker kind of layer, we don't need anything. The only thing we need is logic, right? So the less thing to manage, the better it is, the faster it is, the more scalable it will be. You can develop your applications much faster. You can move to market, you can release new versions of your application in a much better way, right? Okay. So that's why serverless. Now, what is serverless? Let's check that out. So these are the attributes of any serverless service. So no provisioning. You don't have to care about operating system. You don't have to install operating system anywhere. You don't have to manage the hard disk drive or the networking for that matter. Like what is my IP address, which port is available for public or anything, which VPC, subnets, nothing, firewall, anything. So you don't have to manage any of these things. You just have to push a code and it will run. No management as well. What is, if you have virtual machines, if you're using EC2, you have to patch your operating system. If you have Linux or Windows, you have to update your operating system. You have to update your libraries. If there is a new version of Node.js, you have to update it, right? But in serverless, you don't need any of that. The best point, which I like the most, is pay for value. So what is pay for value is that if you are not using Lambda, or if you're not using any of the serverless service, you will not pay. Like if I can deploy 10 Lambda functions on AWS account, and if I don't have any traffic, well, I will not pay a cent. It's literally just free. If you want to understand this, then the best way to understand this is how our electricity works, right? If you have electricity, K Electric, whatever electric company in your city, then If you use it, you pay it. There's a bill at the end of the month and you pay it. But what if you don't pay it, right? Then if you don't pay it, you will not get bill or well almost zero bill. In terms of AWS, it's well it is zero. It's not almost zero. It will be zero if you're not using your Lambda service. Then finally is the scaling part. So if you have EC2 instance, you have to manage the scale. How many servers is required for the number of users of your application? So if you have, let's say, 10,000 users and one server is enough for 10,000 users, then you need one server. And suddenly there is a holiday, there's Eid, there is New Year, there is Black Friday, Cyber Monday, whatever, whatever, and your traffic increases by 5 times, 10 times, then you have to increase your number of servers. Okay, so scaling you have to manage. This is serverless. In terms of serverless, the scaling is managed by the service itself. Okay, you don't have to manage if your traffic increases by 5 times or 10 times. But there are some things which you cannot do on serverless. So serverless, if serverless is so perfect, then why not the whole world is using serverless, right? Well, so these are the few things which serverless can't do. So serverless can't run applications like WordPress, like Joomla, like databases, MySQL, Postgres, stuff like that. It can't scale with schedule. Well, there are alternates to this, but uh, a pure serverless application just increases or just scales based on the number of requests. So if there are requests, the service will work. So the idea is that let's say at 12 midnight you have a huge sale coming up and you know that your traffic will increase 10 times. If to keep it simple, in serverless you cannot increase your infra 10 times because there is no infra. You are not managing anything. You just have the function, right? And the function is already out there. It's up to AWS Lambda to make copies of that Lambda, your application like 10 times, but you cannot manage that. The final point is predictable cost. So if you have EC2 instance, well, there are a lot of issues with EC2 instance, but you get a predictable cost. If it's $1 per hour, then you will be charged 750 something dollars every month. Okay, that's fixed. It the scaling part, the update part is a separate thing, but as far as the cost is concerned, you would know what is the cost. In serverless, well, the good part is that if there's no traffic, well, it's $0, but you would never know that how much bill you will get at the end of the month. So there's no predictability in terms of cost. So it could be good, it could be bad, it depends on how you look at it. Now, serverless and the workshop is on AWS Lambda, but there are other services which are serverless as well. These are the services for storage, S3 simple storage service, where you can store objects in terms of PDF files, images, documents, text files, CSVs, whatever. You cannot have databases running on S3, but you can have individual files. And the best part is you don't have to manage how much you will upload on S3, how much data you will upload on S3. You don't have to manage that. You can upload like terabytes, hundreds of terabytes, thousands of terabytes, and S3 will manage everything for you. Dynamodb, you don't have to manage how much reads and writes you have to provision or how much load, database load you will have, right? It will scale automatically for you. Then there is this Aurora serverless, which is again, you don't have to manage the server part and you will get a database which scales on its own. Next is compute. So we have two basic services, which is AWS Lambda and then Fargate. So Fargate is your Docker containers as serverless. You will not run your Docker on EC2, or you don't have to manage EC2 to run your Dockers. Your Dockers will run. You just provision your Dockers and you will have working, running containers. Today, our focus is on Lambda, so I'm not going to go in more details on what is Fargate. The third is integration services. And there are like, I just mentioned three, but there are like tons of services. SNS, simple notification service, which is very good for email notifications, SMS notifications, HTTP API calls, and many other things. Simple queue services service, which is again serverless. You don't have to manage the server. You just push messages to this queue and it will just receive it. An API gateway, which is most of the time used with either EC2 instances or in front of Lambda to manage the traffic and throttling and security and other things. Okay, so these are the serverless services, basic serverless services from AWS. So let's move to Lambda. So Lambda is what is Lambda? Lambda is easy, high scale, cheap, and reliable service which integrate many other AWS services. So this is the definition part, but when we'll do the actual hands-on lab, then we will know that what is actually Lambda, how it works. What is Lambda? Like you have heard this Lambda terms like 10, 20 times from me, but what actually it is. So we'll look into it in much more detail. But I want to cover a few points before we do that. So this number, 1, 2, 3, 4, 5, 6, 7, 8 zeros and 2, 1. So this is the cost in American dollars and USD for one invocation of Lambda request. One invocation of Lambda. Okay. So I don't know. It's like you have to call Lambda a few million times and then you will pay $21. So if you call Lambda a few hundred thousands, 100,000 times, I don't think you have to pay anything, right? And then this is the cost roughly 20 cents per 1 million request. 1 million is 10 lakh. Okay, so if you have 10 lakh requests in a month, you will pay 20 cent for it. Uh, well, in comparison to EC2, in EC2 you pay for EC2 instance itself. You also pay for the hard drive, EBS. So in EC2 you pay for two things for every hour. Irrespective if you're using your server or you don't use, you still pay. If your server is running, you pay. Even if your EC2 is in a stopped state, you still pay for the EBS, you still pay for the hard drive. Unless you delete the hard drive, you delete the EC2 instance, you terminate it, then you don't pay anything. But if your server is running, you pay for server and hard drive. If your server is stopped, you still pay for the hard drive. Okay. In Lambda, there's no hard drive, there's no server. So the only measure of cost is that if there is a request, if we call Lambda somehow, then this is the value. And then the bottom number is 0.00001 few 67 for every GB second. And this is like how much RAM you want and how much storage you want. Not storage, but memory in terms of RAM. So if you want to learn about the pricing, you can visit this URL, aws.amazon.com/lambda/pricing, and you would know more. And I would ask if you're a student or if you are going to graduate recently, or even if you're a developer, you should start moving towards AWS. And if you are afraid that it will cost you a lot, then these are all the things which you get in free tier. For Lambda, you'll get a million requests per month for free. So if you call Lambda for, I don't know, 200,000, 2 lakh times, it's free. You don't have to pay anything. 25 GB of Dynamodb for free for always, not for 1 year. 1 year you get EC2 instance and few other services for free, and then you pay for that. But these are things which is free forever. 1 million SMS requests. You can send 1 million SMS or 1 million email from SNS every month for free. And then there are so many other services like SQS, CloudWatch, Cognito, you name it. So that's a little bit theory, which I'm going to cover today. And before I move to the lab, since we are almost half time, I'm going to leave this slide here. And if you want to learn, like a lot of people have questions like, where should we start AWS? Like these are the 6 places you can start. These things are not only like theoretical knowledge and you have to read thousands of pages of documentation. These are labs. So you will get access to AWS console. You can get access to AWS services and you can actually use them in a scenario. Same thing which we are going to do today. We are going to create something on actual AWS environment, not just theory. We are going to do something. Okay. So I'll give our host 5 to 10 minutes. If there is any questions, then let's take the questions and then we can move further. No questions until now. Okay. Then let's move on. So this is the URL for quick labs and everyone just open this URL bit.ly/3tct22b. Okay, once you click this, you'll get this. And if the sign up is free, so if you don't have the account, don't worry, it's free. It's not going to ask you for your credit card, and anyone can sign up. It just requires an email address. And we are going to do this introduction to API gateway. It says introduction to API gateway, but we are going to do AWS Lambda. It has AWS Lambda, so okay. So what are we going to do today? So in this lab, we are going to create a API. An API is you call a URL and you get some response. Okay, in the simplest sense. API is the core of microservice architecture if you've heard about it. If no, then maybe you can start. So application programming interface or API as it's commonly known as. It's like if you want a list of users from an application, if you want, if you're, let's say, Kareem, and if you Kareem application wants to get the list of nearby drivers, how will it do? It will call it will call the API on the server, okay, and that's how it's going to get the list of drivers. That's how it works. So API is the core of applications these days. Um, well, almost every application, every major application, I would say, uses API, right? So we are going to create one API, okay, and it's going to work on AWS Lambda. Okay, it's on demand. So if you call this API, you will invoke a Lambda. Okay, if you will not call the API, then there's no Lambda invocation. Okay, so few example of RESTful APIs is Spotify, Twitch, Netflix, Slack, and you can create your own Slack UI, everything on your own from the using the Slack APIs itself. So AWS Lambda is the actual function as is the actual business logic, actual code which will return the values or the data. Okay, and AWS Amazon API Gateway is a service which provides the URL to invoke Lambda. Okay, so that's why we are going to use API Gateway. So I'm not going to go a lot of detail in API Gateway today because our target is to actually do something, actually do a practical. So I hope that everyone has logged in. And once you're logged in and on this page, you click on this Start Lab. Okay, it's okay. Yeah, I'm not a robot. Okay, and it's provisioning. It's going to take few minutes. The lab itself is 55 minutes, but we don't need the whole 55 minutes to do this lab. If you're just going to follow me, you can do this lab easily in 20 minutes. Okay, that's my target at least. So I'll just wait for it to provision and then I'll start. And if you have any questions, please drop it in the comments and I'll try to answer them. Anything about serverless, why we use serverless, why AWS, like what is serverless if you still don't understand it, or what are the benefits over EC2, or if you want to do something which you think that Lambda might be useful, maybe just share it in the links and we'll check it out. Okay, so once you have this open console button available, it means that your environment is ready. Okay, so just click this open console and it will open a separate AWS console for you. So if you have never seen what is AWS or how it actually looks, well, this is the AWS. This is how you use AWS. It's nothing but a website. AWS console is just a website with all of these links and these names, all services under all services. These are all the services with AWS. Right now, AWS has more than 175 services, and obviously, I don't know most of them. Nobody can say that they know all of them, but you have to start somewhere. So you can start from S3, host static websites on S3, or Lightsail, or EC2, or Lambda. Okay, so let's follow these steps slowly, and I hope that you will be doing the same with me. So start lab done. Step two, open console is done. Okay. So before we start, I think it's a good idea if I'll show you around the AWS console. So you can search all the services here. Okay. You can search for services here, and this bar will stay no matter which service we will be in. This is my account number and my user ID. So AWS student at account. Oregon is the region. Region means that actual AWS data center. Okay. So these are all the regions. Please don't change it. It's mentioned in the lab. Don't change your region. So for us, it's US West or Oregon region. So our the Lambda we will create today will be America. Will be in United States of America, US West, Oregon, in the state of Oregon. But we are going to use it from we can use it like from any part of the world. So if let's say we are in Pakistan and you want to spin up some resources for the users in Pakistan, your application, Pakistanis will use your application, then the options you have is, according to me, is US East, North Virginia, which is the biggest region of AWS. Most of the time, it's the most cheapest one also. Okay. The other option is Singapore, okay, which is in Asia and which is again closer to Pakistan than Tokyo or Hong Kong. Hong Kong does not have all the services, so I don't prefer Hong Kong. I prefer Singapore, which is a much mature region and have a lot more services. Mumbai is closest to Pakistan, but it depends on the network. So we don't have direct connectivity with Mumbai, so it uses the internet infrastructure to route the traffic and come back to any part of Pakistan. A lot of people use Ireland, which is again relatively closer, Ireland or London. So Ireland is in Europe, so closer than if compared with America. So a lot of teams also use Ireland region. So either North Virginia, Mumbai, Singapore, or Ireland. So these are the good candidates for region. Okay, so I hope you understand a little bit around the AWS console. So the first task is straight away, let's create Lambda function. So what we have to do is we have to select services, click Lambda, and create a function. So let's try that out. So I'll search here, Lambda. Okay, you can also see from here, Lambda under all services, compute. So I'll search Lambda. Okay, so Lambda is here. So I'll search here, Lambda. Under all services, compute. So I'll search here, Lambda. Under all services, compute. So I'll search here, Lambda. Under all services, compute. So I'll search here, Lambda. Under all services, compute. and it will load the Lambda UI. So this is how Lambda UI looks on the AWS console. Well, obviously there's no functions right now, but there could be multiple functions, APIs, BFF, and websites or anything, right? So let's click this create function button over here, orange color button, and this will show you multiple ways of how we can create AWS Lambda function. So we can author from scratch, means we will write the code by ourselves. We will configure everything. Okay. We can also use a blueprint. So blueprint is like a template. Okay. Few things AWS has generated for us, a template. So Dynamodb process, microservice HTTP endpoint. Uh, so if you have a RESTful API which you have to create, then HTTP endpoint is a good thing. If you want to execute something on Node, then Node exec S3 Python object, and then you can see like there's a lot of templates. Then this is a very recent offering of AWS, that the container, the Docker, you can even run Docker on Lambda itself. So the alternate was Fargate, I mentioned earlier, but now Lambda also supports container images. And then you can also search for public applications. So these are all the developers like you and me, and they have created a lot of different type of functions. So yeah, there's like 53 pages of applications. There are 632 public applications written on Lambda. So maybe for your assignment or FYP or final year project, maybe you can use Lambda, and instead of writing everything from scratch, just pick up anything, just reuse. It's a formal term, it's a better term. Just reuse the code and develop something, right? Okay, so let's see what does it say. It says that what are blueprints. I just explained to you that these are templates. What we have to select is author from scratch. So everything we are going to create on our own. So function name is FAQ. FAQ means frequently asked question. So function name is FAQ. Our runtime is Node.js 12. Runtime means the technology which you are going to use for your Lambda function. So we have Java, we have Python, we have Go, .NET, Ruby, but we are going to stick with the default which was shown here, Node.js 12. Execution role, we are going to select execution role. Execution role means like what are the services which this Lambda can use, okay, in simplest terms. So you need a role for it, you need a access for it. So that is what role is. Okay, so we are going to use an existing role, and the existing role is Lambda basic execution. Second option, use existing role, and if in this drop down there's only one option, just select this Lambda basic. I think my screen, I can, yeah, I think this looks better. So function name is FAQ, runtime Node.js 12. In the permissions, we will use second option, use an existing role, and we will select the one option which is here, Lambda basic. Okay, and then we have advanced settings. So let's see if we have to do anything. And we don't have to do anything, and we'll just have to create function. So create function. Sorry, it's hidden here. So it's here. Okay, click on the create function. Don't touch anything under the advanced settings, and your AWS Lambda function is ready. Okay, you can use it. The problem is that you cannot invoke Lambda directly. You need a URL, right? You need some access to your Lambda. So that's what's next. Your Lambda function is ready. So this is the code. Okay, this is your Lambda function. This is a designer. Okay, you have some permissions, monitoring, a few things, and then behind designer you have function code. So this is the code which will get executed. This is the function as a service, right? So if you know Node.js or JavaScript, then this will make sense to you. But it's very simple. So Node runtime is Node. Handler means the entry point of your function. So which is index handler. So index.js inside we have handler function. So this is our entry point, and you can create multiple other functions here and you know invoke from your handler, and you can create multiple files and many things. But right now we'll just stick to the basics. And then we have so many other tags, environment variable, basic settings. Uh, One thing I want to note down here is memory. So every Lambda invocation will have some kind of RAM attached to it, like how much RAM you need for this function. The more RAM, the faster it will be. Or maybe you need RAM for data processing. So you are maybe reading some files from S3 or Kinesis Firehose and you're processing it. So your files are huge. And that's what this RAM memory is. The second thing is a timeout. So maybe you write a function which just runs forever. You have infinite for loop. Well, Lambda will not allow that. So Lambda will have some timeout. And after that timeout, the Lambda invocation will be terminated by AWS. Okay. For APIs for public endpoints with the API gateway, like if you want to use our Lambda from public internet, then we have to use API gateway. Okay, and API gateway have a timeout of 29, 30 seconds. So we have to keep less than that. Then we have file system and concurrency, and we have so many different things, but let's just stick to the basics first. Okay, the page will be displayed with your function configuration. Scroll down to function code. We already seen that, and delete all the code that appears in that code editor. Okay, select, delete, copy the code shown below and paste it into the index. Okay, I'm just going to copy this from this button. I'm going to paste everything here. So you can see this is a JavaScript. So this is the JSON object which has all the questions and answers. And this is our handler code now. So what you can do is you can go through it and you would know that what it's doing. It's just getting some random number and code selected is random. And then this is the response which we'll get in our API. What is it doing? It's just reading the JSON objects index, index number, whatever is that random number. Okay. And then it's going to finish the function by saying that, yes, it's a success. Console.log, these two lines will log the output. So logging will be handled in the CloudWatch service. Lambda, so AWS obviously has multiple services for different features. CloudWatch is a service which manages the logs. Okay, examine the code. We just did that. Okay, click deploy. So our function is ready. Everything is ready. Changes not deployed. Okay, we are going to deploy it, and we are deploying it. Okay, done. That's how easy it is to deploy Lambda. Now, how are we going to use it? So it says that go to the scroll down to the basic settings and put this uh, description. Description is not a functional requirement. Even if you don't provide any description, it's optional. Your function will still work, but just to show you how to change these things. So memory, and if let's say I want to modify this timeout, just can, and finally I'm going to save it, and then the changes have been saved, right? So my description should be updated. Let's just double confirm. Okay, now scroll up to the designer section. So let's design how our Lambda is going to get triggered. So most probably we'll add a trigger. So add trigger, point number 30, select a trigger API gateway. So I'll click this add trigger button, which will add a trigger. I'll select the first option, API gateway. Okay, and it will show you the simple form. It has API, type, security, and some settings. So let's see what are the values we have to select. API is create an API. Yeah, that's what we are going to do. The second is REST API, and security is open. So we are going to select REST API. We have another option of HTTP, and security is open. Open, I assume that open means everyone can access this. So we need an API name. API name, well, it's already provided. Then the deployment stage is my deployment. I think deployment stage could be development, staging, a different type of environments or versioning. You can use different things. And finally, at the bottom right, click add. So let's just add our trigger. Okay, so now in the Lambda designer, you can see that API gateway is already attached to this Lambda. Okay, now how to call this Lambda function? So in the API gateway, I'm going to click this API gateway, and previously it was Lambda. So if I select Lambda, it will show me Lambda configuration. If I select API gateway, it's going to show me API gateway configuration. Open this details part, and you can see this API endpoint. Okay, and if I open this link in a new tab, then this is the question I get from the list of values it was provided. So what language does AWS Lambda support? Let's see. See, so let's call it another time, and the question changes because we were using random, and this is again one of these questions. So if you examine, this is our URL, and our URL has, okay, so let's our URL has this HTTP protocol. Until this part, this random number is our API gateway endpoint, and execute API tells us that this is API gateway. US2 is our region, and then like all other services, we will have the base URL is Amazon AWS.com/. This is the deployment. As I told you, it could be dev, staging, or anything. And the finally is our Lambda function name, which is FAQ. The API type and other things are mentioned here, right? So I hope all of this is working for you. Let me share my link. I ask Amna to share this link for all of you to use and see if it works. So you can see that I have not decided server. I have not decided any uh, networking requirements. I have not decided any, what should I say? Requirements in terms of connectivity, requirements in terms of where my code is being executed, which server is it, which operating system is it, which version it is. It's just a function. What you get is you just have to write this function and the application is working. So this is a function and this is actually your data. So you can see like few lines and you have everything working. If you want to follow this lab and test the Lambda function, then you can go ahead and test it out, like how to test it and all that. I'm not going to cover this for the simplicity of this session, but if you wish to, then I hope that you have some time here. And the best part is that this quick lab is free and you can do it multiple times as much as you want. So if you are not clear in the first round, okay, let the lab end and then restart it and do it again. Okay, and I hope that this concludes my basic simple workshop, and I hope that you might have learned something out of it. So as a final step, what I'm going to do is I'm going to show you this QR code. So if you want to email me and if you want to ask any question, I'm should I study computer science or software engineering? I have 1 degree in computer science and 2 degrees in software engineering. So if you want to ask me that question, if you want to ask me like, should I study in Malaysia? Should I study in Pakistan? Should I work outside Pakistan? Should I do freelance or get a job? Anything, you can email me. So my Sure Solutions is my part-time hobby. I do a few projects under this company, and my personal website is hussain.dev. I would be very thankful to you if you go ahead and scan this QR code and fill this form. So this QR code is not for me; it's for Amazon to get the feedback from our community, like how much interest is there in Pakistan for AWS. And if many people will fill this form, then we will have more freebies. We will get more free sessions, workshops, the whole seminars, and hopefully someday we'll have full day AWS events by AWS in some part of Pakistan. I would really love that. So please fill out this QR code and also fill out the feedback form for AWS Community Pakistan so that the amazing team can have more such sessions and collectively we all just learn out of it.
Sir, there is a question in the comment section. What if we use Python and have a large data set like more than 5 GB CSV file to work with? How much computation would I require?
Okay, so if you want to parse the whole 5 GB file in one go, I think that's a bit tricky because let me try to see if that's possible. That I don't think Lambda will allow you to have 5 GB of memory. Okay, Python is not a problem. Python is fine, but I don't think it will allow you to have, oh, well, it has a 1 GB of memory. So the alternate is that either you divide that file into smaller sections and read that and process that. Alternate is that in triggers, you can have a lot of other services like S3, and you can store your data in S3 and pass it from S3 itself. Okay, that's one way. The other way is you can attach Elastic File Storage, Elastic File System, EFS, which is here, and you can store up to 5 GB is a small value. You can store up to like 5,000 GB file, and Lambda can parse it. But again, there are some limitations in Lambda. You cannot run Lambda for 10 hours. You have to divide your processing into smaller chunks. That's what I would say. Any other question?
Sir, the other question is, can we attach the SQL database to AWS Lambda?
Yeah, definitely. You can. In your code, you just have to write a connection string. You just have to mention connection string of your RDS database. Your it could be RDS or it could be your database running on EC2 instance anywhere, and you can use a database. That is perfectly fine. Okay, you can. That's not a problem at all. You can also use DynamoDB as your database. MySQL, Postgres, a lot of Microsoft SQL Server for that matter, Oracle database, anything.
So there is an announcement that the attendance form link is in the description and it's functional now. So please fill that form in order to mark your attendance. So, thank you, sir, for joining us today and giving the youth some gainful skills and tips. And it was a great pleasure for all of us to listen to you. And also, thanks to our sober audience for turning in today. That's all. And thank you, everyone, for your time. Allah Hafiz.
Thank you.